I would like to introduce our esteemed panelist, Don Harper. Don is a global applications engineer with Amphenol Communication Solutions Business Unit SSIO. With over 40 years in the connector field, Don specializes in supporting customers with new product design and development and uncovering T10 Standards Committee storage products. Thank you for joining us today, Don. You may begin.
Oh, thank you. Well, I wanted to welcome everybody, and it was interesting updating this slide because I realized how old I'm getting. And this group of people in my age are a dwindling group, but we carry all this experience. So hopefully my experience extends beyond yours, and I know some things that I can share with you today, specifically around the field of artificial intelligence and what are kind of connectors apply to the field of the storage and server market. So let me tell you a little bit about myself. As you can see my picture here, I've been doing connectors for quite a while. I graduated from college in 1983, and my first job was with a connector company. And I'm from Pennsylvania. The largest connector company at that point in time was Amp Incorporated. And I worked for a small company, and then I worked for Amp Incorporated for a long time, and then I moved to the Amphenol group. But one of my accomplishments was a design award that was given at DesignCon many years ago, and it was around the MegaRay connector. So my experience started off with product development, and fortunately, I was just aligned with some projects that were very successful and gave me the opportunity to get a bunch of patents, a bunch of awards, and be part of a team that did some amazing work. But today, what I want to talk about is my responsibilities over the last 10 years have been focused on the storage and server market. And just this week, one of my hobbies is photography, and I was seeing firsthand how AI is starting to show up in so many places. And photography and image recognition was one of the first places that AI started. And right now, when I edit a photo, I have so much power behind that because that photo goes back to a server somewhere and gets analyzed and identified, and I get to interact now with this program that's going on, and they can identify things, change things, mask things, and even regeneration is now the big word, where AI can regenerate and add information into into your files. So my job right now is supporting the storage industry, and my customers are our global tier one customers like Seagate Systems, Seagate, Western Digital, Intel, and Micron, and I support all the products associated with those customers. Today, we want to talk about the different products. But let me tell you a little bit about Amphenol. Amphenol actually has a complete organization built around the storage and server industry. And I'll go through this really quickly, but just to give you a perspective, we have factories around the world, and our design center is actually in two different locations, Chengdu, China, and Singapore. And I'll be actually in Chengdu in a couple of weeks, so I get to travel around. But what you can see from this slide is the footprint for our Amphenol locations and how we cover all the products that I'm going to talk about, like DDR4, DDR5, M.2, and others. So this is our agenda today. I just kind of showed you a little bit about our Amphenol group called the SSIO organization, and we do focus on the storage and server market. Today, though, I want to kind of do a quick review on the standards that are associated with the storage market, because there's a lot. All these companies do come together through standards organizations to achieve some intermatability and some other things through the standards group. But today, what we want to talk about is all those connectors, the M.2s, the memory type of connectors, the DDRs, and also the SAS type of connectors. And then finally, there are board-to-board and compression connectors that we see trying to connect boards inside these. And then I want to show you a little bit about my view of what the future looks like and what kind of things you might expect to see in the next couple of years. And at any point in time, you're welcome to jump in and ask a question, and we will finish with some questions. So if you can jot any questions down, you could wait till the end as well. I generated this simple AI picture in the cloud there just to give a view on each slide what might be associated with artificial intelligence and how's Amphenol supporting that. So this is an overview slide showing the various products that support the server and storage applications. And I would guess that you see these pretty regularly because in some way they are almost commodity type of products. There's M.2. We have our own product line called Cool Edge, which is a card edge type of product. And I'll talk about that a little bit more because that includes the Gen Z, the EDSFF, which is the most popular, I think, card edge standard right now for SSDs. And then there are the traditional form factors that you see there, the U.2s, plugs and receptacles, the DDRs, and the PCIe's that we sell as well. All of these products are connecting with AI, partially because AI is driving the need for more data and faster data, and all these products are in an evolutionary state where we currently have a form factor, but we are working on the next generation products. And that's kind of our message today. And you'll hear that as we take a look at each one of these products, where we are, and trying to answer any questions you might have. I wanted to start off with just one standards organization, just to show you kind of what takes place in a standard. At one point in time, I was the representative on our T10 standard, and that covers a lot of the storage industry. But the PCIe group now is, I think, the primary standard that everybody's kind of moving toward. And as you can see in this chart, if you go around those boxes on the outside, there is working committees, electrical working groups, mechanical working groups, and there's even marketing groups that look at how we market and how we pick names for all these things. But as you can see, it's very complex, and our customers all gather together, typically monthly, to work on these standards and participate in each of these groups to help define the performance, help define the mechanical form factor, and it'll make more sense too as I'm going to start talking about a lot of different standards and how they're associated with our connectors. One group in that standard, which is extremely important, and what's going on is the evolution of all of our connectors to be able to run faster and faster. The card edge mechanical group is probably the biggest group, and one maybe that's been working for the longest time. And one of the things that they define is the mechanical form factors for the mating interface. Right now, we have Gen 5 products released, and we're working on Gen 6 with all of our customers. And they are asking us as well to have next generation products. And one thing that I believe Amphenol represents is a technical advantage in this high-speed electronics area. As you will see through this presentation, all of our products are in this evolutionary state where we're providing the current form factors, running the current speed, but we're working with our development partners through standards and other ways to be prepared for the next generation speeds that everybody's asking for. One quick way to get a good overview for this is to kind of look at some evolution of all these different connectors. And this chart shows that in a way that I think is very helpful. And it might actually help you answer some questions as you're interacting, picking parts, and working with customers. But if you look to the right side where I have an arrow showing the pitch, and that is the contact pitch of our connectors. So each contact is spaced apart. In the first column, you can see as at a 1 millimeter pitch. And that was actually the first card edge product that came out. It is the PCIe standard, and its contacts are at 1 millimeter pitch. So if you move to the left, you start seeing all those numbers starting to shrink and get smaller and smaller. And that has been, as new connectors have been needed, the pitch or the density has gotten smaller to be able to get more contacts in the same amount of space. And so I'll look at a couple that are really important. So there's 8.85, there's 0.8, there's 0.75, 0.65. And when you get to the 0.6, that is the current standard for Gen Z and the EDSFF. So we'll be looking at those standards, and all these different connectors fit into different standards, and for different reasons, the pitch has been changed to make a higher density product. One other thing to note is the M.2 is probably one of the oldest next to the PCIe. When it came out, it was pretty revolutionary because it doubled the density in the column that shows the 0.5 millimeter pitch. That is that includes a bunch of standards. One maybe not quite as popular, the NGSFF standard, but the M.2 is a very common standard. It's used in all these servers and storage boxes. I hope that makes sense. The latest thing that has come out is on the furthest left column, and it shows a 0.4 millimeter. I have to believe you're starting to see this through distribution as well, because it has doubled the pitch to a very high density. And as I work with customers, they're constantly wanting more and more high density pins in their applications. And this gives them a way to double their density with a card edge connector. There isn't a standard associated with this yet, but at some point in time, it likely will become a standard. So if I talk about all those connectors that are on the list that we just showed, we're going to walk through them. And the first one is this PCIe connector. As you probably know, that this is a card edge connector that takes PCIe cards, which there's all kinds of different sizes and versions. And we are currently working in the standards group on the Gen 7 spec. We're right at Gen 6 already in making samples. So we have tooled up the next generation, and we're already looking ahead. This one somewhat leads the electrical group because it is the older standard and because it has so many applications through a PCIe card. PCIe cards could include things like NVIDIA graphics cards and memory cards. And as you can see, it comes in sizes from a 36 position the whole way up to 164. And we do have higher pin count versions. Some of these aren't defined in the standards, but our customers need these larger pin counts, and they are designing their applications with those. One thing that Amphenol does is we work a lot directly with our customers. And so there is a lot of customization that takes place. But once our customer has identified a solution that seems highly valuable to them, we try to take that and offer it to the rest of the marketplace. And here's one solution that we're finding. And I have our little AI symbol in here because we're working with customers on things like density and speed. But we call this this connector our flip chem connector. And with the flip is shown in that right-hand view on the side. The standard chem connector, as you can see, that green card gets inserted from the top. It comes down into the connector. And our contacts kind of have SMT tails that fan out on both sides. Some of our connectors have come, some of our customers have come to us and said, hey, would it be possible, and it would help us in routing out our connector, and we could move this connector closer to the edge of our cards and save us a lot of space. So we save our customers some space, and we allow them to utilize more of their printed circuit board. And we do that through this flip chem connector. And it basically changes the soldering part of the connector to this configuration. It looks like an L or a J. And it's one way that Amphenol customizes many different of our applications for specific customers. That may not come through distribution, but eventually this flip chem, I believe, now is on our website. And we'll talk about our website too. Hopefully that hasn't drove anybody crazy yet. We continue to improve, but there's ongoing work too. The storage group is actually, I think, has one of the better portions of our websites. So moving on to the M.2 connector, currently we do have our Gen5 M.2 connector. What took place from Gen4 to Gen5 is somewhat connected to artificial intelligence, because there's this great expansion of the industry and needing more and more data, faster and faster. It drives another part of that, and that is more current is required to drive these additional kind of functionality inside these applications. And so the M.2 generation moved to a higher current version. The form factor, the pitch, all stayed the same. The speed or the data rate continues to increase. And as you can see, the Gen 5 increased now up to 32 gigabits, which is the Gen 5 standard. And it increased the current per pin from a 0.5 amps per pin to a 1 amp per pin to give our customers this whole thing of the cards that plug into this demand more power, have more things in them. The SSDs are now getting put into an M.2 form factor. I expect you see a lot of M.2 business coming through our distribution. And we offer it in various stack heights and in various configurations as well. The next standard that I wanted to show you is the EDSFF standard, and our internal product is called Mini Cool Edge, and it covers this group of standards that you can see here. The best way to look at this may be confusing is let's start with a quick view on the right-hand side. There is a standard in the SFF group that is TA1002, and it covers this EDF standard, which is the card edge standard for the SSD applications. Covers the mechanical portion. It even covers cables. Cables is something that will be the future of a lot of our electronics. I'm not sure how this specific market will be moving towards cables, but it will be, and I do believe that distribution will at some point be looking at providing cables right now. There are the most common cables that go through distribution. In this application, these are high speed type of cables, and they're very unique at this point in time. Sorry, the sidetrack on cables. Let me go back to these standards, the SFFTA 1002, the EDSF standards. They are a card edge connector that comes in a 0.6 millimeter pitch. And if you move and look to the left side, this somewhat confusing chart, across the top is how they identify the number of contacts or the size of the connector. There's 1C, 2C, 4C. You know, I can never remember all these numbers, so I keep this chart somewhat handy. It's helpful to see this. And what it tells me is where we stand with all of our products. So for this particular standard, in the 5 different versions that there are of the connectors, across the going down the left-hand side, this defines the orientation of the connector. I'm assuming this makes a lot of sense to you, and I'll show it in a little bit of a picture coming up. But there's a vertical version of this connector. There are 2 different right angle versions in the standard. There's a straddle mount connector version, and there is an orthogonal version. I'll take a little bit of time to just make sure that that's clear. And how it interacts with all these other, the mating side of that we'll talk about. But if you look at that chart, and if you just look at all the green boxes, which is the most popular one, it shows you that we have 3 different sizes of a vertical connector. We have 6 sizes. I'm sorry, we have 3 right angle, we have 3 straddle mount, and we have a couple different versions of the orthogonal pulled and ready to go. Let me show you what they look like in application, how you use them. And I think if you're looking for connectors and working with the storage customers, these are going to be very familiar for them. And they may come to you saying, I need an EDSFF connector in a 2C version. And as you can see, Amphenol has that in vertical, in a right angle that has a 4.05 height to it, in a straddle mount version, and in this orthogonal version. And here's a picture that kind of shows the 3 different orientations. I believe this makes sense to you if you've looked at components and if you're working with connectors. This is kind of the basic communication of how the connectors sit on the board. And as you can see, a vertical connector gets a card plugged in that orientation there. The right angle usually goes on the side or the edge of a connector. This is just showing here, for example, the different sizes, but we have right angle connectors as well. The most popular size for the standard right now is the orthogonal orientation. And that's driven by, on the right hand of this slide, you can see the standards that are underneath the discussion that we previously had of the SSD side. You may in your interactions hear these terms thrown around, the E1, E3. What I'm showing right here is just a couple versions of the E1 standard. And this is on the mating side, the card side. So it's defined as well in these standards. And what you can see here is a bunch of SSDs, and some people call these the ruler connector. These can be maybe 15, 20 inches long. And if you could imagine, they slide right into a rack and into a storage server. They're designed to fit in a one-use space. And the orientation that most of these would interact with is the orthogonal. So in that little design towards the bottom, you can see how an orthogonal part would sit on a mid plane or a back plane, and then the SSD would get plugged into the front half of that. I expect you'd hear these standards, the E.1 and the E.3, are being talked about and being used pretty frequently in all the new designs. All the card edge products are shown here in a sample type of demo board. This might be something that if you have some storage customers that you work with, it might be nice to have some of these boards, and certainly we're happy to be able to support distribution and our customers with things that would help you and help our customers. This is just a quick summary of where we are with this specific Cool Edge products moving towards Gen 6. And rather than try and remember everybody, this is pretty dynamic. It's constantly changing. The message to take away is we're working on the Gen 6 product. We have tooled up versions of it, and it all kind of connects with the demand in the market and our lead customers and what they want to develop for the market. So Gen 6 is certainly coming. It's driven a lot by artificial intelligence, and that means more data, more power, and higher density, trying to get more and more squeezed into smaller spaces. Hey, when I was putting this presentation together, I took a look at our standards, internal standards group puts out a monthly update on all of our standards. Amphenol is so large that we literally have multiple people covering multiple standards, and that's their full-time job. We realize that all these applications, our customers are looking for a way to have connectors for those, so they get together in standards. And one of the latest ones is they're starting to realize they got to get more and more power into these cards. So they are now coming up with new standards that add the ability to have power contacts integrated or into a separate type of power. And you can kind of see an example of that in a NIC card, where these cards have a lot of functionality to them and they require more and more power. And what that translates to us is our systems are getting hotter. And our connectors are getting hotter because we're running more and more power through it. And that's kind of one of the demands that we're facing. Our customers have to solve this as well with fans and different cooling technologies. And it's some of the crazy stuff that they're looking at to get higher and higher power, such as liquid cooling and building these cloud servers up in Antarctica so they can take advantage of the outside temperature. I believe I've been told many times that the largest cost to our customers in running a server and a cloud, I think we all know that a cloud is literally just lots of hard drives in these racks and racks and racks, creating a way for our customers to interact with all this data, store this data, and actually manipulate this data as well. Here's a new standard that's coming out. I think it's just in the standards group, but it's centered around enabling more current and power into these systems. And it's driven by this higher functionality. This is a very old standard, the DDR. Everybody probably has sold lots of these things and knows this. A card plugs in, and this has this unique little clips on the end to be able to lock a card into place. Nothing earth-shattering here. The point of this slide is Amphenol is continuing to support all the DDR products. We have our DDR5. It's fully released. So I'm sure these products are on our website, and you're already working with these. We do offer these in a zillion different variations of latches, latch heights, hold downs, and all this. I expect you work with our customers. You're working with your customers to offer these kind of solutions. DDR5 is definitely connected with supporting AI. One of the greatest demands is the speeds and accessing memory. So these memory connectors are getting loaded up inside these storage and server boxes to be able to access the memory as fast as possible. Another version of the DDR5 is something called the SO-DIMM. It's just another form factor of a card edge. It has different connections, but what you can see there is the form factor is staying, the mechanical form factor is staying the same. And that's really important to our customers. And that's what somewhat these standards are about. Our customers want to maintain the mechanical form factor as they go forward. So there's backwards compatibility on all these products. And so they have a future generation path forward for the next type of product. So they want our connectors to basically sit down on the same type of space, the same printed circuit board designs, but be able to function a lot faster. And so that's what our engineering groups are doing. I'll talk about this a little bit more on a U.2 connector, just what has it evolved to, but be aware that on all these new, especially memory related products, more and more memory is being driven by the artificial intelligence requirements. The other big one that goes into servers is the SFF standard, and it covers the SAS, the SATA, and these standards. You can see it here in maybe a traditional form factor. This looks like this would be representing maybe an HDD form factor. And most of our products are these U.2 and SATA receptacles. What's shown in this picture is a PSAS plug on an SSD, and it's got to get plugged into a receptacle on our customers' boards. And so this standard is this has been just evolving for ages, which you probably know. It started out as SAS, and now it's called PSAS, and I'll talk a little bit more about it. So what is our next generation products for this specific standard? It is a combination of SAS and PCIe, and that's why it's been given this kind of label name. It's probably hard to keep up with all these acronyms. I live with them, but so when somebody says, hey, do you have an SFF 8639? I totally know what that means. That is this version of a SAS connector that has PCIe lanes and functions at PCIe speeds. It probably looks a lot like the SAS connector, and it is in its form factor. So it is a SAS interface that has been updated and designed for these next generation speeds. And to give you a picture of this, what typically has to take place on these performance improvements is shielding and grounding and SI electrical fine tuning of the contacts. So we try to keep the mating interface geometry the same. And what we've added in these to get to these speeds is 3 ground bars, a couple over molded parts, and then a finished design that our customers don't see all the things that are going on inside. But believe me, these are the most complicated and sophisticated connectors that we've ever seen. And that's part of the reason why they're starting to cost more and more. To get this kind of performance, it takes a lot of engineering and a lot of sophistication that's built into it. A lot of times it's not completely visible. This slide's just giving you a view. Hey, we're already working on our Gen 6 products for this. So we are working with our customers who are building drives, SSDs, and HDDs. and they are coming out with products that will run at Gen 6, and we're working with them and the standards group to have our products ready. Typically in the standards groups, we lead first with our signal integrity support, and then we typically are the first to tool up samples for our customers to evaluate, measure, and build their products. That brings me to the end of my presentation. Thank you again for joining. This slide just says one more thing, and that is on our website, we have a section that is specifically set up for the storage and server market. And in this page, which I show here, you can go directly to any one of these standards that we just talked about, and it will hopefully help you pick parts and support our customers better. The takeaway message is Amphenol is a technology leader, and all these products have been evolving, and we're working with our partners to have our next generation products in the market and in lots of different variations and sizes. I wanted to end with just one thing here. Talking about my time at Amphenol, one of the coolest things that I got to do while I was here, and it's a part of the awards that I received, was to develop this MegaRay connector. And down in the left-hand side, you can see the original design, the first design of experiment that that I had the opportunity to work on. And it all came out of just one observation that we realized as we were building these connectors. It was the first BGA connector that was ever made. And we realized that the BGA soldering process and the surface tension of solder causes these connectors to self-center so accurately because of those properties that the connector position was extremely accurate relative to the geometry on your printed circuit board. And what that told us and what we explored and found out is now we can use multiple connectors in a single application, because we don't have to be concerned, our customer doesn't have to be concerned about locating the connectors. It will locate itself. And right now, if you bought a graphics card from NVIDIA, you would find multiple MegaRay connectors inside a lot of their products. So they take advantage of a very high-speed connector in multiple connector applications to get things like 1,200 contacts in a very high-density location. And this quote here is a quote from Albert Einstein, who we all look at as one of the most smartest people in history. His comments were he didn't really have any special talent. He was just very passionate about being curious and asking questions and going to find answers. And that is a principle that has been part of my career, and it's led to a lot of success. I want to encourage you to be passionate about your curiosity in the connector field, and good luck to you. I hope that you use lots of Amphenol connectors, and thank you again for joining this seminar.
Thank you, Don. That was fantastic. And that is all the time that we do have left for today. So if you have any questions after, please do not hesitate to reach out. I just want to say thank you to everyone for joining us today, and thank you, Don, for your time in discussing PCIe Gen 5 and Gen 6 storage and server interconnect solutions.